Today I'm going to talk about data visualization, and that's a topic that's very close to my heart. I covered most of it in the introduction. I'm also here with a message from the Data Visualization Society. I'm on the advisory council of them. Can I see if anyone is part of the Data Visualization Society? Okay, so this thing is taken off like crazy. In the last 5 months, there are more than 6,000 users on Slack, and it's a fire hose that I can't keep track of. So it's awesome, and I would encourage you to just join it and at least see what kind of things people are talking about. I teach data visualization at USF to computer science students, and I've also taught last year at the Data Science Institute in downtown as part of our Masters in Data Science program. And I've been teaching our Introduction to Computer Science in Python class for many years at University of San Francisco. So what am I here for? So I'm here because I really want us to make an awesome environment for all of these new people who are coming to data science. So think about articles like this one, which says Python overtakes R for data science and machine learning, right? Obviously, it's sensational and it sounds cool. And my first excitement, because I'm a huge Python fan, is yay, this is awesome, because I don't like R that much, because I'm a computer scientist. And part of it is because I've been in the data visualization field for a long time. And so I'm excited and I'm passionate about data visualization. And I think that everyone should be doing it, obviously. And so my second emoji is, oh my God, there is so much in the data visualization field that's still not available in Python, right? And so in this talk, I'm actually not going to focus on one library. I'm going to use examples from Matplotlib, Seaborn, kind of with Matplotlib, and Altair that maybe you've heard of. It's a very exciting library from Jake. And then Plotly and Geoplotlib. Geoplotlib is not as well known, but it's great for like geographic visualizations. And so I actually wrote a Medium post last year after teaching a course in the data science program. And I was like, okay, this is just because I was frustrated that the data visualization field has these techniques that are available only in D3, and JavaScript kind of sucks. And so I was like, why can't I just stay in the Python world? Why can't I do something that's Python only? And I was shocked because people actually seem to be still reading it, and clearly it resonated with a bunch of people. And so what are the goals of my talk today? So the first goal is to share some of the research-based findings from the data visualization community and give you a little bit to think about and hopefully give you some advice in terms of things you could do practically on a day-to-day basis. And secondly, I also want to kind of talk about the fact that there are many visualization techniques that are out there that are just not available for users in Python. And I think as a group, as a community, we can bridge this gap slowly but surely. Simple things like tree maps, parallel coordinates, edge bundling, it's just not available. And this is not something that came out last year. This has been out in our community for more than 5 to 10 years. So I think we can all do better. Okay, you can't listen to a data visualization talk without some commentary on pie charts. Anytime you talk to a data visualization person, they will say, pie charts bad, stay away from them. And part of the reason is that as human beings, we are very bad at comparing areas. We are very good at comparing lengths, and this has been validated in this older study by Cleveland and McGill in 1984, where they basically looked at our human visual system, and they found that there is some kind of efficiency where you have position and length are things that we can compare very easily with minimal effort. Whereas as you go down the chart, if you go to area, then it becomes much harder. And then ordering things like intensity, color, and shape is just much more hard for human beings. And so anytime you talk to any data visualization person, they'll say, don't use pie charts. And I'm not going to tell you not to use pie charts. I'm going to tell you, use them with labels. And more importantly, if you are going to use pie charts, make sure that you use them for the appropriate representation, right? So the appropriate time to use a pie chart is when you are trying to communicate part to whole relationships, right? If you want to eat 1/4 of a pizza, that's great. Health choices discussion later, but maybe that's 25% of your pie chart, right? That should make sense. And I'm going to use this a few more times. With great power comes great responsibility. Why do I say this? Because I want you to be careful with the number of parts that you might use in a pie chart, right? What is the problem here? The problem here is that the developer of this tool, Abomination, was like, this is a challenge. I am going to make sure that any user can make a pie chart, how many ever parts there are in this pie, right? And that's a problem, right? Because our visual system cannot deal with this. What are you trying to convey here? And so first thing is be careful with the number of parts. And what did I tell you about the second one? What? No, not now. The second one is must add to 100, must add up to 100. And so if you go to a data visualization talk and someone talks about pie charts, you are going to see this chart. So this chart does not add to 100. So be careful with using pie charts. That's all I'm going to say. Okay. Second thing, we all know this, but maybe this is for some other person, maybe a friend. So use line charts carefully, right? Again, line charts are great for things that have a connection on the x-axis. Use it for time series data, time on the x-axis, but it is appropriate for temporal data like that. What does this line chart mean? Who cares? It should be a bar chart, right? Why does a tool allow me to do this? Because someone said, I will make it work. No, it should not be possible to make a chart like this one, right? A bar chart makes sense. These are 4 separate entities, and you can easily see that CBS has the highest viewership rate. Obviously, no one watches any of these channels anymore, so that's a different story. So we talked about pie charts, we talked about line charts, but you might be like, you know what, Alark, I really like line charts. I'm going to use them. And you should use them. They are excellent for representing some kind of trends over time. You can communicate information extremely efficiently using line charts. We understand them, right? So the whole visualization literacy piece is important. People use bar charts, pie charts, line charts because you've been doing that since like 3rd or 4th grade, right? My kid comes home with bar charts and my data visualization parent is happy about it. So when I see line graphs, I'm like, yeah, that's because you want your users to understand what's going on. But there is so much visual clutter in things like this, right? So while you can see interesting patterns in this, what we recommend from our field is consider something called small multiples. What small multiples does is it separates all the different entities into smaller representations that allow you to see and explore individual items one at a time, right? So I saw this chart and while I was making this presentation and I was like, wow, Y1 killed it. This student was able to get less than 0 points on some exams. So very, very impressive. And then Y5 clearly had some kind of a problem because Y5 was trending in the right direction, the brown chart in the middle. And then something happened around week 8, and then week 10 was probably finals week, and it worked well, right? If you look at this chart here, you can probably see some of these things, but they are not as apparent, right? And yes, and so 2 of them are of the same color, which also causes problems. So one of the important things I want you to take home today is visual clutter is bad. If that's the only thing you take home, that I'm fine with it, and you will see that thread throughout today's talk, right? And on the top here, I have a small image on the top right that tells you which library I've used. I'm also going to post a link on a GitHub link at the end of my slides, which has all the code and the data that you can look at. as well as some resources for you to learn more about data visualization. Okay, again, you might say, well, I've read some interesting data visualization books, and they said we should use, the legend should be the same color as the line chart. Too much visual clutter, not really able to see any interesting patterns here, separated out into small multiples, and now the colors don't even need to be there because you have individual multiples, like individual charts that show all the different patterns. So now you can actually see that region C is doing well, and you can see that there's a pattern going upwards in region C. So good stuff. But small multiples by itself aren't like powerful enough. What they allow you to do is they allow you to compare across charts, right? But the comparison is only powerful with interaction, right? And so what I would encourage you is to try and think about having interactive, think about interaction whenever you're using charts. Whatever charts you might be making, whatever tools you're using, don't just think of it as it's going to be a static chart that's going to end up in a report. Think of it as this is a chart that I can use to explore the data while I'm performing experiments, but also at the end when I want to communicate this data to someone, let someone play with the data. Don't pre-digest the story and tell them that, look here, this bar chart is awesome. Let them interact with the data and find something in the data. That's when you will find more interesting results coming out of it. So here is a simple example of small multiples with interaction. As your mouse pointer moves, you can see exact values, because data visualization is not supposed to hide anything. You are supposed to actually make things clearer. And if you give people numbers, they are going to believe them a lot more and be able to compare things much better than if you just show them charts. Okay, so that brings us to our favorite Scatterplot. Everyone loves Scatterplots, and tools now let you do all kinds of overloading with Scatterplot, which means now not only do you have x-axis and y-axis, but you are going to be like, hey, I have color. Now I have shapes. Now I have sizes. So I can overload this Scatterplot with all kinds of different things, right? But what did that chart tell us about increasing difficulty? What it told us is that the more you overload the user, the longer it's going to take them to read the data, and the longer it's going to take people to see things that you really want them to see clearly. Again, a data visualization is not a puzzle. It's supposed to be something that conveys information as quickly as possible. So this is actually a chart that's visualizing the Golden State Warriors from 2018-19 season, and looking at age and weight on the x-axis, points, the total number of points scored on the y-axis, and we had the number of years in the league. So then you can use that for color. We use shape for position, the position that the player plays, and it's kind of busy, right? If you use small multiples, you can kind of see that we only use color for position because that is a categorical variable, makes sense, and you stick with that. And then, while I was playing with this, I was like, wow, look at the difference in the bottom left in the points and weight section. There is a 1,000 point difference in 3 players, I wonder who they were, and the rest of the team. So clearly, Kevin Durant, Klay Thompson, and Steph Curry scored a lot of points, but the rest of the team, there were players who didn't, basically scored 1,000 points less in total than the rest of than the other 3 players. So that was pretty apparent to me. And yeah, you might be like, yeah, Alark, I can see that in here too. Great, good job. No, but my point is, this is a lot less overwhelming, and you can see things much more clearly, and you can focus on things that you care about. Okay, so and you might start seeing these things. It's one of those things that once you hear about it, you see it everywhere. And so as I was preparing for my talk, I ran across this amazing Tableau workbook that shows you the change in house prices in England and Wales over the years. So it basically just shows you change over 1 year. And so 96, 97, the size of the circle shows you the change, and the color is actually how much it's changed. So red is bad, blue is good. And so 2000, or is it the other way around? Price increased. So red is bad for people who are buying a house, but good for realtors, I guess. So 2000 to 2005, everyone was like, let's buy a house. It started getting more and more expensive. 2009, economies collapsed, a bad time to, and so prices reduced significantly, right? So this kind of data is very hard to communicate in a chart if you think about it. And through small multiples, they were able to communicate 12 years of data very efficiently. Okay, this brings us to Choropleth Maps. It's not chloro, it's choro. It comes from a Greek word. Because people think about colors, they think this is Choropleth map, but it's not. So this is something that you see frequently again. The idea is, it's very tempting to do this because you're like, hey, I have county data. I have counties on my map. I can color the county with the data, right? Wrong, because counties are huge, some of them, and they are just in the middle of the country. There are massive counties, like this chart that you might have seen a couple of years ago, where everything looks red and it gets abused a lot. But the point is, the point is that this doesn't tell you the truth, because again, you are looking at areas, and areas can be misleading, right? There are areas in Arizona, there are massive counties in Arizona that have maybe like 5,000 people living in it, whereas there are huge there are smaller counties in the Northeast that have a higher population density, right? So think about what you're trying to communicate, right? A Choropleth map can be very misleading because area doesn't really mean anything there, right? The area that a county has doesn't have anything to do with the value that you're trying to show. You might be like, well, Alark, can I at least use symbols? Because, come on, give me something here. And so, so yes, you can use symbols. Symbols are great. Here is a simple one with state capitals scaled according to their population. And you can see that, like Idaho and Montana and things like that those places have much lower population than places like California and Texas, whose capitals have a much bigger population. But these have problems too. Visual clutter is everywhere. So this is just showing you all the airports in the United States. And I haven't even scaled it, because if I was to scale the Chicago O'Hare Airport, it would take up all of Illinois probably, because it's the busiest airport in the country. And we looked up a lot of data to find that before I made this. So this is busy, right? Like if you want to just show the airports in the United States based on maybe the number of departures or maybe number of arrivals or number of passengers going through it, show them a horizontal bar chart that is scrollable. That's fine. It doesn't have to be this, massive macho test of can I put everything on one chart. Not necessary. So you will see things like this in The Economist, where you might see that they have tried to use transparency to get around this whole problem of occlusion, because one circle is so big that the circle under it cannot be seen. But there are parts in the south that have just so much going on in it that you have to question, what is the goal of this visualization? What are you trying to communicate here, right? And so again, maybe bar charts are useful. They communicate what you want to communicate. Maybe in this case, if the intended goal is to communicate that there are more detentions along the southern border, that's probably the only thing I can get out of this. Okay, moving on, because I'm going to stay on time. Again, visual clutter is bad. Edge crossings are visual clutter, right? Again, just because a chart or a charting library allows you to make this extremely busy and intricate network diagram doesn't mean that you should, right? So there are things in our field. One of them is called edge bundling, and edge bundling basically allows you to do something very simple. It takes edges, I don't know if this is big enough. Yeah. It takes edges and bundles them based on their common paths. So I'm a little more comfortable around 0.85 or so, but 1 is a bit too much for me. But around that point, you can see that you can see clusters in terms of connectivity. You can see that there are certain clusters in nearby regions, and you can also see almost like highways, where connections are emanating and where they are arriving. And so obviously this example is much more convincing because it has interaction in it, and interaction improves everything, which is my next slide. So this is probably the second thing that I wanted to take away with you today is let your end user, it could even be you while you are just exploring data, you are trying to play with the data. Let your end user have some interaction. Let them interact with the data, because our visual system is much more complex than we give it credit. And while machine learning is awesome and I love it, I think we should still allow us to find patterns in the data, and that can only happen through human and computer working in a loop rather than just you expecting the computer to do everything. So there are lots of different interaction techniques. You're all probably familiar with filtering, which just removes the data away, but there's also brushing, which basically highlights relevant details. So you can do something as simple as, here is a scatter plot. I just want to pick a certain region, and you can imagine that if you picked this region, then you might be able to see some summary statistics for that region. That let's say, looking at student scores or house prices, then it would show you maybe the house prices in that specific region, right? So again, use the algorithms, the statistical algorithms in tandem with interaction. Hovering might get a bad rap because it sounds like a lame interaction technique, but it's actually very powerful because it allows you comparison, not just interacting in terms of let me put my mouse on a bar chart and get the value, which is also incredibly powerful because then a user doesn't have to try and trace it to the y-axis. But even something as awesome as this, where you can look at a specific value for, let's say, category A, but then you can compare it across category B and C and see exactly where it lands for comparison. You've probably heard of cross-filter, and cross-filter is kind of awesome. This is just an example where you're looking at 231,000 flights, and this is what I was talking about, where interaction and visualization work hand in hand. So let's say we pick all the flights. This is only a few months of data, and you want to try and figure out, something interesting from it. Since I'm going to be short on time, I'm going to show you that if you take an early morning flight, then the average delay is actually quite good, maybe on time or maybe even a little early. You might reach earlier in the day, but if you take a late flight, just keep looking at this chart here. If you take a late flight, you can see that the delays get significantly higher. So don't take that red-eye flight for more reasons than one. So what happens with this is, these are just bar charts that I'm interacting with, right? But you can look at 230,000 different data elements, quickly filter it, and interact with it to find something interesting in it. Okay, oh my goodness, animation. I don't even know where to start with this. People get excited by animation. They just love it somehow. And in our visualization field, people just hate it. So you probably, if you are a data visualization junkie like me, then you probably saw this trend a few months ago. This whole bar chart race thing was super popular, and people were like losing their minds. I didn't even pick examples. I was like, I'm just going to show them the Twitter search for this because there are just so many examples and not necessarily all bad. I mean, I think what happens with something like this is that it gives you, if you time it right, it gives you higher user engagement, check for social media. B, it slows things down, and so people are going to, actually observe things rather than maybe not. And it kind of communicates change over time, which is a good thing, and animation can be good for that. But as Tamara Maznar has said in the visualization analysis and design book, it basically, animation can help you when you're transitioning between two different visualizations, different data configurations, right? And you may have even seen this talk by Hans Rosling where he is like super animated and he uses this motion chart where there are these countries and they have these different things like population and world events, and they all work together and communicate change over time. But as human beings, we actually know that you can only remember about 3 to 5 seconds of the data that you've seen so far. And so if you see a longer animation, you've basically forgotten everything that you saw up to that, before that. Okay, so in our lab, we actually experimented with animation in multi-class scatterplots. So on the left is you have a categorical value, which is ratings. And so you have different things like general and PG and PG-13 and rate and all that. And you can pick one in this visualization. And what you see on the left is that the selection that the user has made is highlighted in red, but there are all these like gray dots on top of it. Like if I pick something, shouldn't that be on top of everything else? But it's not, because this is a busy chart and the order in which the scatter plot is made seems to affect the way it's rendered. And so what we did was we said, well, what about using animation? What if you had this almost flickering effect where each dot in the scatter plot kind of gets its time in the sun, right? So if you pick something, then there's going to be animation which will allow you to kind of observe heterogeneity in a region and also observe homogeneity in a different region. So while we understand that this is not something you would put in a presentation to like the CEO or something, it might be something you could use to explore data and observe patterns in the data where your algorithm is not deciding what needs to be occluded and what isn't. Instead, you are actually getting some clarity in terms when you are exploring the data. Okay, the next thing, I know many of you work on machine learning algorithms. Convey uncertainty. Again, convey uncertainty. Again, convey uncertainty, because that is not getting conveyed, right? We use these things which I don't know when we learned it in like 5th grade, called error bars, but that's sometimes an afterthought. And we've actually seen some research from Michael Correll and Michael Gleicher that says that error bars in bar charts are actually considered harmful, because some people think that all of these values from 0 to like let's say 2.7 are possible values, right? So people perceive everything in the bar as possible, whereas what we know is that actually what's on the right is the closer to the truth. That is the truth, right? You have the average value and you have some error around it. Use things like fan charts, because fan charts tell you what are the possible outcomes for projections and forecasts. So things like this can help people who are making decisions based on your visual representation. The unfortunate truth is that, as Enrico Bertini's lab found out, that people trust charts way more than they trust text. And so if you show them something that looks like this, they're going to be like, wow, bar chart, must be true, right? They are not going to think back and say, oh, well, wait, let me know a little bit about the data. There's a lot less skepticism when they look at visualizations. And so it's almost our job to introduce a little more uncertainty and help them understand that, hey, this is a real possibility. And this happens every year during hurricane season when people need to evacuate. They're like, oh, that cone does not include my house, and so I'm not going to evacuate, right? Like that's not how it works. And so actually Alberto Cairo worked on different representations for showing hurricane paths, and that was an interesting project. Okay, so I know I'm going to run out of time very quickly. Annotations draw attention. Again, visualization is not a mystery novel. It should be clear for someone to understand what's going on. You've probably seen this project, but I'm going to run it on fast. You can see this. There are different things that people do. This project is from Flowing Data, and they basically looked at what do Americans do at different times of day. And so you can see that people are sleeping. It's still 8 a.m. This must be a university town. And then people are going to work. Still, some people are at leisure, living the dream. And so there's a lot going on here. You'll be like, Alark, you told us no visual clutter. This is all visual clutter. But it works because there's annotation, there's interaction. I can slow it down, I can slow it way down, right? And then these annotations here give me an idea for what's going on, why are things the way they are, right? Help your user see what you're trying to see. Don't just put a chart in there. Add some annotations in there, let people see what you're trying to see, right? Am I out of time? Where is yeah? We are completely out of time? Okay, so then I'm just going to end by saying that data visualization can be used for exploration, maybe an analysis, obviously, as well as communication. But think about the audience when you're thinking about communication. Data visualization literacy is real, and it's something that you need to take into account when you're putting your data visualizations out there, whether it's the New York Times or whether it's a scientific paper or whether it's an internal document. You have to think about the visual representations that people will know. I'm going to end my talk by quoting Ben Schneiderman. He's an awesome professor of data visualization, and he says the purpose of data visualization is insight, not pictures. With that, I'm going to end my talk. I'm happy for questions, and most importantly, all of my code, data, and resources for you to learn more about data visualization are on that link on GitHub.
Thank you so much, Alark, Joshi.